Okay, so we had a demo stage on the first day, and Padraic was one of the demos, and Padraic is one of the demos today as well. So we'll be looking at Infarm a little bit behind the scenes and learning something special here from Padraic, who is the team lead for crop genetics at Infarm. Padraic.
Thanks a lot, Suds. Yeah, so as Sud says, I'm team lead of crop genetics. And my job is to try and create the crops for the farms of the future. And today we're talking about innovation, and perhaps the most important innovation of the past 15,000 years, the innovation which is the foundation of civilization, and without it, nothing of what we have here around us today would exist, is agriculture. And despite its importance, and despite its age, in key aspects, it hasn't changed since the beginning. We still, to this day, have no control over the environment that we grow our crops in, or very limited control. We do have irrigation and some other technologies like that. And I think this, for us to be able to go forward, especially in our destabilized climate, we need to look at this and think of ways where we can innovate so that we now have that control, which can bring us to the next steps. And in order to be able to do that, we need a strong R&D program. We need a lot of innovators, as we heard in the session before. We need entrepreneurs. And we thought it would be nice to give you a little tour of some of these people working in this area. So we're going to play you a video showing a little bit of a behind the scenes of what goes on, at least in Infarm's R&D hub. And after that, we'll follow with another video. But first we do this one, and then we take it from there. If we can. Hello, welcome to Infarm's Research and Development Lab. My name is Padraic Flood. I lead the crop genetics research here at Infarm. And today I'm going to take you on a tour of our research facilities. But before I do that, I want to show you some of our production towers. This is where we're producing the food of the future. And to ensure that that food is as nutritious as possible, that we can provide the widest range of products, and that we can do it in the most resource use efficient and sustainable way possible, we have a very advanced research agenda. And the people that lead that, I'm going to be introducing them to you. The first person that we're going to talk to is Almeen. She leads the crop biochemistry research team here, the nutritional biochemistry research team here at Infarm. And her goal is to ensure that the food is as healthy as possible. Almeen, can you tell us a little bit about the research that you're doing here today?
Sure. So in nutritional biochemistry, we are measuring those metabolites that are of interest for our health, so beneficial and nutritious. And in the nutritional biochemistry team, we're basically focusing on extracting those metabolites from the plant material and quantifying them. And we have been working on our pipeline to optimize this, to also be as sustainable as possible, to reuse, to reduce, reuse, and recycle. We have one workhorse that's doing, where we do most of our analysis on, the so-called high-pressure liquid chromatographer or high-performance liquid chromatographer. And here I show a chromatogram to you for ascorbic acid, also known as vitamin C, which we quantified in our strawberry fruits. Having an absorption maxima here of 243 approximately to identify this. Yeah.
Thanks so much. And to ensure, thanks so much, Almeen. And to ensure that vitamin C is still in those strawberries when it gets to your plate, Lucia leads the post-harvest research team. And this is all about making sure that the product is as high quality as possible when it gets to the consumer. Lucia, can you tell us a little bit about the research that you do?
Okay, thank you. So in post-harvest research, we actually focus more on optimizing the crop performance of different commodities with the aim to maintain the visual quality, aroma, nutritional value, and also the marketability of the product, with the aim to deliver the best quality product to the consumers. In order to do this, we actually do various types of methods to determine the quality. So one of the methods is to measure the gas exchange in the package. This is important because it actually helps us to optimize the package. And if we have the optimized package under optimized supply chain conditions, we're able to deliver the best quality product. And this will ensure that we contribute to the reduction of food waste. Thank you.
Thank you so much, Lucia. Yeah, reducing food waste is really key to improving the sustainability of our food supply chains. We've looked so far at what we can do to optimize what's inside the plants, what we can do to optimize the quality of the end product, and now we're going to talk a little bit about what we do to make sure our plants are as happy as possible when they're growing in our facility. And to ensure that, Vivi here is going to introduce you to this, and she leads our crop quality team. Vivi, can you tell us a little bit about the research that you do here?
Thanks, Padraic. Yes, of course. So the key for us is real-time monitoring. So what we do is that we monitor environment information and plant-derived parameters that we can gather with this type of devices, as we can see here. And combining these two data sets, we can create a system in which we adjust the environment according to what the plant needs. So basically, the plants are telling us on a daily basis, several times a day, what they need, and we just provide to them exactly what they require. In that sense, then we can optimize the energy efficiency of a growing system for food production in a way that we take the precise architecture to the highest level. Basically, that's how it is.
That's great. Thank you so much. So thanks to Vivi's research, we're able to optimize resource use efficiency, but also, very importantly, we're able to talk to our plants, or they can talk to us. And this allows us to diversify our range of crops, which is key to be able to move to the next generation of crops. And leading that research over here is Cesar, who's going to talk to you a little bit about what we're doing in that direction.
Yes, so fruiting crops in general are a very complicated crop to grow in indoor farming, but we're doing our best in order to produce them in a way that it will be more sustainable and more resilient for the future. Strawberries in general are a very susceptible plant to pests and diseases. Reason why in conventional farming, there is a lot of people that uses chemical pesticides. In our system, a closed system, a very clean system, we managed to grow strawberries year-round with the best taste without using any kind of chemical pesticides at all, which allow us to give us resilience to the client and year-round production with the tastiest strawberries at all time.
Thanks so much. Yeah, so thanks to the work that Cesar is doing, we have clean strawberries which are produced close to you and can be top quality the whole year round. And this aspect of resilience is really key to what we do in terms of indoor farming. And one of the crops and one of the research projects that I'm very excited about, which is bringing us to the next level in terms of resilience, no matter what the climate, is wheat. And Shanda's going to introduce a little bit about what we're doing with wheat.
Absolutely. So as Padraic was mentioning, so we are currently running an experiment on wheat. And based on our previous trial, we already established a system that allows us to grow wheat in our vertical farming system. And we already achieved a quite high yield compared to the data from the field, from the greenhouses. And our next step will be further optimize our system and try to achieve an even higher yield. And what we're doing right now is to test the different planting densities. And we want to understand under what planting density we can maximize the yield. And our ultimate goal is to not only grow wheat in the vertical farming system, we also want to grow the highest yielding wheat in the world. And we believe that is the key to provide long-term food security and climate resilience. So I just finished sawing this tray, so I'm gonna bring this one to the simulation chamber where we will have this wheat growing. So let's go and check it out. So the growing system we'll be using is a system that we have full control over the majority of the environmental conditions. For example, the temperature, the light intensity, CO2 level, relative humidity, and et cetera, et cetera. So we believe that by doing so, we can make sure that the plants are growing in a very optimal environment throughout their lives. So this is a chamber. Take a look.
Thanks so much, Shanda. So I hope you've seen today the kind of work we're trying to do to ensure not only is the future secure in terms of food security, but it will also be secure in terms of flavor. And thanks so much for joining us. Bye-bye. What a cheesy ending, huh? I couldn't think of anything better. So we spoke a lot today about innovation. And the next project is, I think, especially considering what we have coming to us in our future, innovation on its own isn't enough. You also need the vision and the ambition and the guts to go out there and do something which other people might think are crazy, which other people might think isn't going to work, and they're very cynical about it because the only metric they judge value by might be money or something like that. And well, we're not afraid to go out there and try something different. And this next video is certainly in the indoor farming community, something which I think is really pushing the boundaries and also is key to us being able to achieve the impact we've spoken about. I mean, it's no secret that salads and herbs alone, growing those in indoor farming, isn't going to change the world. But the next generation of crops, the one that we spoke just at the end of that video, wheat, might. So have a look at the next video, and then I'd be happy to chat to you about that afterwards. So this was an experiment that we just finished last month, the video that you saw there, and I actually have some of the wheat that we grow. So if you want to have a look and a smell or whatever, I'll just let it be passed around. As the video mentioned, we can grow now 26 times the average yield of an average hectare. This is only the beginning. I'm pretty confident that we can increase that by at least 50%, maybe even more. And if you look at the area grown by, let's say, the 5 biggest crops, which is maize, wheat, barley, soybean, and rice, that's about the size of Australia in 1 year, so in 2020. If you were to have at least the yield increases we've shown 26 times, that would reduce to something the size of Ecuador, and that's without even considering that you could layer it. So if you make 2-layer system, it's by half, and if you increase the yields further, well, you can see where this can go. I think this is really key, both to food resilience, as we mentioned there, as I mentioned at the beginning. The thing about farming that hasn't changed is that lack of control, that fact that we are susceptible to the external environment. Even though we've been doing it for 15,000 years, we've never really solved that problem, which means many civilizations in the past have collapsed because they didn't have control over that, because the weather changed and they lost their food supply. Indoor farming allows us resilience going forward, something that is really key for us. But not only that, because it's so much more space efficient, it allows space for other living organisms, for life, for biodiversity, and for that biosphere integrity that we need for planetary resilience, not just food supply resilience. I know of no other way that we can effectively decouple food production from ecosystem destruction as well as this. And I mean, I'd be happy if any of you have suggestions in that regard. So yeah, I hope that you're as excited about this as we are, and that yeah, we can talk about it more. So if you have any questions, I'd be happy to take them. Yes, please. We need a mic, maybe?
It's good afternoon. Hello? Yes, good afternoon. Thank you. My question is, to some degree, are you reducing nature's ability to innovate, i.e. sometimes you come up with different strains of...
Sorry, I can't hear you.
Oh, is this better?
Maybe
No.
you shout.
Is this better? No?
Hello, hello.
Oh, hello?
Yeah.
Oh, okay. Are you somewhat reducing nature's ability to innovate itself? For example, with crops growing, you know, uncontrolled or whatever, new pollination, new fruits, new strains could be developed naturally, but indoor farming would seem to limit that. Just a kind of a question or observation.
Yeah, that's an interesting question. Haven't been asked that one before, actually. So I would say no, for a few reasons. First of all, if you think about nature's ability to innovate, that is independent. That's like all those wild ecosystems. By giving them back more space, they have more capacity to innovate because innovation in evolution, it's a numbers game. In terms of food systems themselves, most of that innovation, I assume you're talking about improvement or breeding or adaptation, local adaptation, that already occurs under a very controlled setting, except let's say for land races. And in the controlled environment setting, the way we want to design our systems is they will continuously evolve. So we've designed them in such a way that they will literally never stop improving, like quite literally, until the heat death of the universe. There is no limit to which the genetics of this setup will stop improving. So if anything, we're enhancing nature's ability. And importantly, because we have a stable target, we have a stable environment, the improvements from one year add up to the next year. When you have a fluctuating environment, which is changing all the time, and you're a plant breeder, and disease is evolving, or the environment is changing, the work that you do today may not be relevant in 10 years' time, and you've got to start from scratch. That doesn't happen in our system. So I would say in many ways we enhance the ability of our food systems to adapt. Any other questions?
Hi. From a cost perspective, how do you foresee like implementing Infarm projects in areas that might not have, the facilities or capacity to actually build out this infrastructure for controlled environment agriculture?
Yeah. So I mean, Infarm, I suppose, can build it anywhere. I suppose that we're allowed to build it. Other industries, other governments, or other companies, how they do it, I don't really know, to be honest. I suppose the cost aspect needs to be put in perspective. Yes, it is expensive. There's no getting away from it. And right now, it wouldn't compete with conventional farm products. But that's because the true cost of that food is not properly priced in. The environmental degradation, the subsidies that are put in there, it's subsidized by the governments of today, but it's also subsidized by future generations. When you price that in and when you play the long game and look further ahead, it starts to make sense. How that actually happens is a bigger question, I think, that doesn't just apply to indoor farming, but applies to our food systems in general. And it's something that was spoken about a lot in the previous panels, is how do we provide the finance and the investment in general for these new innovations globally and for them to actually get to scale. And that is something which, as a plant geneticist, I don't think I'm really qualified to answer. But I think it's a very important aspect of it.
Thank you very much for this nice presentation. I understand that so far that it's a highly controlled production system and it's based on electricity input, more or less. And we see a lot of land use conflicts in the world from agriculture, nature conservation. So that's due to space constraints. To consider this production system sustainable, it should be produced under renewable energy production. Do you have any estimates how much land is needed, for example, for solar panels to produce the electricity that you need for your controlled production systems? So
Sure.
is this maybe
what's
a trade-off?
what's the real footprint? Not just the footprint of the farm, but the footprint of all the other things needed. Maybe not just the energy supply, but maybe the mining and the materials and everything. So if you take a full holistic view of it, I don't actually have a number for you because it depends on a lot of things, and I think we're still trying to figure that out. What I would say is that because you can locate them anywhere in the world, you can do it in places where that larger footprint has a minimal impact on the environment. For example, in deserts and places like that, because you can bring the water in, you bring the nutrients in, and it's effectively a closed system. So you can actually produce food there in a very sustainable way. And that way, you are taking space, but you're taking space which has a minimal biodiversity impact, right? The other thing, of course, you could locate it in places where there's very energy-dense supplies like geothermal in Iceland or other places like that. If you're producing wheat or rice or anything like that, it's different than other vertical farm crops in that it doesn't need to be produced near to the consumer because it's very easy to store and to ship. stays good for years if you store it correctly. And then finally, one technology that I think we shouldn't forget about, which has a much smaller physical footprint and is carbon neutral, and I think could have a role to play in this, is also nuclear. And I think we should look at all options. And exactly the footprint of each of those, I don't really know. I think that's something we need to work out. And it's definitely something that we need to think about. But we need to also bear in mind that the context and where we can locate these would mean that that footprint would have a much smaller impact than the footprint of conventional agriculture of the same size. Because that has to occur in places that are more productive and that where there's more life in the first place. So its biodiversity impact and its impact on biogeochemical flows and all those other things is much more severe.
Thank you. Thanks for your questions. Thank you, Padraic.
Thanks.